Hey guys, welcome to our very first video of the last unit of the year, Unit 6, where we're going to be studying momentum and impulses. So let's start our video. We're going to start a discussion of momentum by focusing on just momentum, and we'll talk about impulse in just a second. So momentum, you probably heard that term a lot, especially if you watch a lot of sports. A lot of sports announcers will use the word momentum when they're referring to the team who just keeps scoring points over and over again. They say that they have a lot of momentum. So what does that mean? Well, when we say that a team has a lot of momentum, what that means is basically that it's really hard to stop, okay? They're hard to stop or hard to beat. So, for example, if you have your favorite football team and they've been winning game after game after game, the coach might say, okay, we have a lot of momentum going into this game, meaning we've been doing really, really, really well going into this game. And the other team might say, they have a lot of momentum. I don't know how we're going to beat them. What that really means is they're saying this team is going to be really hard to stop because they've been doing so well for so long. So momentum in a physics sense has a similar meaning. Momentum in a physics sense is basically mass that's in motion. Okay, the more momentum that an object has, okay, the greater the momentum that an object has, the harder it is to stop. And momentum really has two variables that make up momentum. Mass is one of the variables and motion is the other variable. So the more momentum you have, that means either the faster you're going or the heavier you are. So if we wanted to increase momentum, okay, so if you want to increase your momentum, you either need to increase the mass of the object that's moving, or you need to increase the motion or the speed. Okay, so if either of those increase, your momentum increases. So, for example, if I have a really big semi-truck, okay, and then I have one of those tiny little smart cars, okay, both of them are moving at the same speed. Which one has the greater momentum? Well, momentum is made up of two things. It's made up of speed or motion, and it's made up of mass. So do they have the same mass? They have the same speed. Okay, maybe they're both going 10 miles per hour. Okay, both of them are going 10 miles per hour. But the smart car is obviously going to weigh less. Okay, so this has less mass. And the semi is obviously going to have greater mass. So which one has the greater momentum? It's going to be the semi-truck because it's got greater mass. Okay, if we have two smart cars, okay, they have the same mass, but let's say this one is traveling at 25 miles per hour and this one's traveling at 10 miles per hour. Which one has more momentum? Well, they don't have the same speed. This one has a greater speed, greater velocity. This has less velocity. So this one is going to have the greater momentum. Think of momentum as the force caused if you got impacted by it. So which car would it hurt more to get hit by? Well, the one going 25 miles per hour versus the one going 10 miles per hour, because it has greater momentum. Same thing here. You'd rather get hit by a semi going 10 miles per hour than a smart car going 10 miles per hour because the semi truck has more mass, so it's got greater momentum, so it's going to impact you more. So now if we could take a look mathematically at what momentum is actually the mass of the object times the speed of the object, the velocity. Momentum can be written like this. The symbol for momentum is P. The reason why we don't use M is because M is already used for mass. Okay, so P stands for momentum, mass, M stands for mass, and then V stands for velocity. So this is our formula to calculate momentum. It's a very simple formula. Looks a lot like F equals ma. The units for momentum are kilograms times meters per second. That should make sense because we know mass is kilograms. It's being multiplied by velocity, which is meters per second. So kilograms times meters per second is the unit of momentum, or P. Okay. So what I want us to take a look at right now is the type of relationships between momentum, mass, and velocity. So that we can tell the relationship between these based on the mathematical formula. Something you should know from algebra is that if two variables are on either side of the equation from each other, they have what's called a direct relationship. Okay? If we have two variables that are on the same side of the equation as each other getting multiplied, we have what's called an inverse relationship. So looking at this, we can tell that P and M have a direct relationship because they're on either side of the equation. We can also say that P and V have a direct relationship because they're on either side of the equation. But M and V are on the same side of the equation, so they have what's called an inverse relationship. So now let's talk about what each of these are. A direct relationship is when one variable changes, another variable changes the same direction. So for example, we said P and M are a direct relationship, and we said P and V are a direct relationship because they're on opposite sides. Now, P doesn't equal M, okay? So I'm going to draw a line here. It doesn't equal M. It's just directly related to it. So let's take this definition and apply it to momentum and mass. When one variable changes, let's say momentum increases. Well, what's going to happen to our mass? The other variable should change in the same direction, so that means it also increases. And we know that because we just talked about that, right? The more mass you have, the more momentum your object has. Same thing with P and V. The more or really I should have written it maybe the other way. The faster your object's going, the more velocity you have, then the more momentum you have, okay? Indirect relationships are when the variables are on the same side of the equation as each other, like this, M times V. Okay, so they have what's called an inverse relationship. That means when one variable changes, the other variable changes in the opposite direction. So if we want to have the same momentum, okay, P is going to be constant. P is constant. It's not going to change. We want to make our mass greater with the same momentum, then our velocity is going to have to slow down. Our speed's going to have to slow down. Same thing if I do the opposite. Let's say I decrease my mass, but I want to have the same momentum. That means I need to move faster. So mass and velocity are indirect, or also called inverse relationships. P and M and P and V have direct relationships. So, I just kind of answered this question. How are P and M related? Well, they have a direct relationship. So when one goes up, the other goes up, or when one goes down, the other goes down. Okay, same thing with P and V. They have a direct relationship. When one goes up, the other goes up, or when one goes down, the other goes down. M and V, since they're on the same side, they have an indirect relationship. So when one goes up, the other will go the opposite direction. Or when one goes down, the other will still go the opposite direction. Okay? So let's do some example problems. The easiest types of problems to use, for example, are sports-related analogies because momentum plays a huge part in specifically football. So here's a halfback. He weighs 60 kilograms, which is actually pretty light. A tight end weighs 90, and a lineman weighs about 120. Notice the mass is getting greater here, and that actually has a big part to do with their role in their team. So a lineman, their role is to stop the other opposite lineman from going across the line. And so the greater the mass that a lineman has, then the greater momentum they have. So the greater force they have to stop the opposite person. Okay, so here's an example of them running. The lineman runs 3 meters per second, the tight end runs 2 meters per second, and the halfback runs 1 meter per second. So let's say they're running at these speeds, which is pretty slow. And let's say we want to compare the velocities. Well, how many times greater is the velocity of the halfback than the tight end? Well, here's the halfback. The halfback has a velocity of 1, and the tight end has a velocity of 2. So the tight end has twice the velocity of the halfback? Okay, how many times greater is the halfback to the lineman? Well, the lineman is 3 and the halfback is 1. So we would say the lineman has 3 times the velocity of the halfback. Okay. So now it says which player has greater momentum. Well, we should be able to calculate momentum using our formula. Momentum is mass times velocity. So let's do our lineman. His mass was 120 kilograms. We're going to multiply it times his velocity, which is 3. Okay, and so we get 360 kilograms times meters per second. That's his momentum. The tight end is a mass of 90, okay? And we're going to multiply it times his velocity, which is 2. So his momentum is 180 kilograms times meters per second. The halfback has a mass of 60, okay, times his velocity of 1, means his momentum is 60 kilograms times meters per second. So which one has the greatest momentum? It's still the lineman, right? The lineman has the greatest momentum because he has the greatest mass and the greatest speed. Okay, so greatest mass and greatest speed means greatest momentum. This last question here says if the tight end, okay, here's the tight end, if he doubled his velocity, so his velocity is 2, if he doubled his velocity is now 4. How would his momentum be affected? Well, let's go ahead and put that in. So his mass is 90. Now instead of 2 for speed, we're going to put 4. Okay, so we're going to do 90 times 4 now instead of times 2. We get 360 kilograms times meters per second. So his old momentum was 180, right? His new momentum is 360. We want to figure out what happened. We put old on the bottom, new on the top, and we take 360, we divide it by 180, and we get 2. So if he doubled his velocity, his momentum was also doubled. Okay, now you can do this mathematically to figure out, like I just did, or you can just know that velocity and momentum are directly related. So if velocity increases by a factor of 2, your momentum will also increase by a factor of 2, always. Since they're directly related, whatever the velocity increases by is going to be the same value that your momentum increases by. So using that idea, let's answer this question. If the lineman increased his weight by 25%, so the lineman's weight was 120 kilograms. If he increased his weight by 25%, we're going to multiply it by 0.25. Anytime you want to multiply by a percentage, you have to move your decimal over twice. So 120 times 0.25, his new weight is now 30 kilograms. That's his new weight, okay? How will his momentum be affected? Well, we can do it mathematically like I did above, or you can know that mass and momentum are directly related. So if mass increased by 0.25 or 25%, then your momentum should increase by 0.25 or 25%. So what was his old momentum? His old momentum, we're doing the lineman. Okay, so old momentum was 360. So I want to find his new momentum. I take the old momentum. I'm going to change it by the same factor here. So 360 times 0.25, and I get 90 kilograms times meters per second. That's his new momentum. Now, I could also do it mathematically, so let's do it mathematically. Here's his new mass times his speed. His speed has not changed, and his speed was 3 meters per second. Guess what? I still get 90 kilograms times meters per second. So either way, you should be able to get your answer. But remember that whatever you do to your mass, it's going to do the exact same thing to your momentum because they're directly related. If the halfback wanted to increase his momentum, if you want to increase your momentum, what are 2 things he could do? Well, we know he could either increase his mass or he could increase his velocity because both of them are directly related. Okay, so now we're going to move on to this concept called impulse. And I wrote a bunch of stuff here that I want you to read. So you can go ahead and pause the video at this time, and I want you to read this first paragraph here. Okay, now go ahead and pause the video and read this second paragraph here. Okay, so after reading these two paragraphs, you should have a good idea of what an impulse is. Impulse is a force that is against the motion for a period of time. And we know that a force, if it's applied against the direction of motion, is going to slow down our momentum based on this idea right here. So this guy right here is giving an impulse in this direction. He's pulling the guy. This guy's momentum is in this direction. So an impulse has to be opposite of the direction of momentum, or also the direction of velocity, because momentum and velocity go the same direction. So to sum up, let's talk about velocity. Velocity is just, our change in distance over our change in time, okay, meters per second. Momentum looks like this. It's mass times our velocity, okay? And an impulse is shown by this formula. Impulse is the force that you're exerting times how long that force is being applied. Okay, so a bigger impulse, if you want to have a bigger impulse, then you apply the force for a longer period of time. If you want to have a bigger impulse, you could also just apply a greater force. Impulse is also known as the change in momentum. It's also known as the change in momentum. The change in momentum would be mass times the change in velocity. So impulse is actually all of these formulas right here. Okay, it equals the force times time, but it also equals the change in momentum, which is mass times change in velocity. So before we get into the math of this, let's do some conceptual example problems. Here's case A. Originally, this guy was going 5 meters per second. Then, over the course of this amount of time, that's 2 seconds, he slows down to a speed of -3 meters per second. Okay? So he was going 5 meters per second, then he slowed down to -3, and he did that over 2 seconds. Let's look at case B. Here, his speed is 3 meters per second. Okay, and then over the course of 2 seconds, he slows down, and now he's going -1 meter per second. So let's look at these questions. Which one has the greatest velocity change? Well, this was at 5, okay, and then I need to subtract my second. So actually, I'm doing it kind of wrong here. Remember, if you want to find change in velocity, it's final minus initial. So my final time was -3. My initial time was 5. So I get -3 minus 5 is -8. So really, we have 8 meters per second. We've changed 8 meters per second. That's for case A. So this is A. For B, our final was -1 minus our initial was 3. So it changed, 4 meters per second. So case A had greater velocity change. So which one had a greater acceleration? Well, acceleration is the change in speed over time, right? So in case A, the change in speed was 8, and it took 2 seconds for it to happen, so its acceleration is 4. In case B, the change was 4 meters per second over 2 seconds, so its acceleration was 2. So case A still has the greatest acceleration. So as long as the time is the same, the time it takes to stop is the same, the one that has the greater velocity change will also have the greater acceleration change. What about momentum change? Well, how do we calculate change in momentum? Change in momentum up above is shown by mass times the change in velocity. We're not given mass here, so we're going to assume that mass is the same for both situations, okay? If the mass is the same for both situations, then what it comes down to is whatever one has the greater change in speed also has the greater change in momentum. So situation A had the greatest change in speed, so it also has the greatest change in momentum. So which one has the greatest impulse? Well, impulse is force times time. We don't have force, we only have time. So we can't really calculate impulse. But impulse is also this formula. Remember, impulse and momentum change are the same exact thing. So if you don't have force or time, you can find impulse by doing this. And so it's going to be the same answer as the one above. We're going to skip this one because it's the same exact problem that we just did before. Okay, so now let's combine these by coming up with a formula and do some practice problems. So impulse is force times time. Okay, that's one formula that we'll be using. Momentum is mass times velocity. That's our second formula. So here's our first formula. Here's our second formula. Our third formula is going to be a combination. Our change in momentum is m times change in v. But change in momentum is also force times time. So we can combine them by looking like this. Force times time is m times change in v. So that's our combined formula. Both of these sides equal impulse. So this is impulse and this is impulse. We usually refer to impulse as being force times time, and we refer to change in momentum as being this, but they're the exact same thing. So these three truths are really important. The impulse experienced by an object is force times time. The momentum change of an object is mass times velocity change, right here. The impulse is the same thing as the momentum change. So impulse is the same thing as momentum change. So I'm going to do two problems with you here. Example 1 and example 2. Okay, and both of these you should be able to figure out any of the leftover answers. So we're given time in example 1, we're given mass, and we're given our velocity change. So what are some of the things I could calculate? Well, we know that momentum is mass times velocity. Okay, we can't calculate momentum because we need to have velocity, not velocity change. So we can't find our momentum. We can find, however, our momentum change because we're given mass and we're given change in velocity. So let's calculate that. Mass is 10, velocity change is -4, so my momentum change is -40. So that goes here. What else can we calculate? Well, we know that impulse and momentum change are the same thing. They're always equal. We also can calculate our force because the formula that has force in it looks like this. Your impulse equals your force times your time. Well, we have time right here. We also have impulse because it's the same thing as momentum change right here. So we can find force by doing our impulse divided by our time. So our impulse is -40. Our time is 0.010. I'm recording a video. So when I divide these, then I get -4,000. So -4,000 is my force. Okay, let's do one more. One more problem right here. Whoops. Okay, so in this problem here, I'm given time, momentum change, and mass. So let's look at the formulas. Well, if I have momentum, change, and mass, I could find my change in velocity. So I'm going to do change in momentum divided by mass gives me change in velocity. So change in momentum was -200, mass was 50. So if I do -200 divided by 50, I'll get -4. So that's my momentum, that's my velocity change. Okay. Now, how do I find impulse and force? Well, impulse is the same thing as my momentum change. Okay. So how do I find force? Well, it's the same way I did last time. Impulse is force times time. So to find just force, I do impulse divided by my time. So if my impulse was -200 and my time was 0.010, I can divide them and I get -20,000. And that's my force. So that's it for our video today. Go ahead and do your practice problems listed right here. There's 4 of them. Please make sure you do all 4 in order to get credit, and I will go over the answers in class.